Hi friends, welcome back to CADable. This is Engineer Ibrahim Omer, and in this tutorial we will learn how to create G-codes of a turning operation in SolidWorks. Recently I have received a comment on my CAM tutorial that was related to milling operation, and basically he is asking about how to create turning operation in SolidWorks. I'm using SolidWorks 2020, but if you are using a below version of SolidWorks or a future version of SolidWorks, you can still follow this tutorial. So here I will be creating a turning operation of this circular part in SolidWorks. So first of all we will model this and then we will create G-codes. I will cancel it. I will go to here new, select part and select OK. And now I am in SolidWorks interface. So first of all, as usual, I will change my background to plain white. And I will set my units to mmgs, that is millimeters gram second. So I will go to here front plane sketch, and here I will create a center line like this. Let's make it horizontal, and let's say this dimension is 65. So I will start with a line. This diameter is 30 and this diameter is 20. So I will select this point and I will select this center line by holding the control button, and here you can dimension it by the diameter. You can see, let's make it 30 and let's make this dimension as 20. Let's make one line like this. This dimension is 15 millimeters and this dimension is also 15. Now we will make one 3-point arc like this, and this radius is 15. This vertical dimension is 10 millimeters. Now we will make one step. This diameter is I think 25, and we will make one 3-point arc like this. This radius is also 15, and this dimension is 15 millimeters. And now you can see the sketch is turned into black, which means it is fully defined. Now we can use the revolve command. So go to here features, revolve boss space, select yes, and now you can see the preview of your circular job. Select OK. Now we will apply some material. So go to here material, right click, edit material, and here I will choose a aluminum. So I will go to here aluminum alloys, and let's say I will select this one 6061 alloy, select apply and close. And now you can see aluminum alloy texture has been applied, and here you can see as well 6061 alloy is your material. Next is I will go to this gear icon, add-ins, and I will select this option SolidWorks CAM. Okay, if you are using any older version or newer version, you can also choose your CAM accordingly. So I will select this one, SolidWorks CAM 2020, select OK. Now I will go to here SolidWorks CAM, and then first of all I have to define the machine. So click here define machine. So there are two kinds of machines, either it is mill or it is turn. So I will select this one, turn single turret, and I will select it. Also here you can see some options like tool crib. You can see different tools. Here you can see our machine. You can see the post processor and all. So I will select OK. Next is we will define the stock size. So I will go to here stock manager, and here you can see the material is already applied. Here also you can choose your material accordingly. So currently this is the round bar stock, and here you can see the preview as well. Basically, a stock is the material from which your part will be manufactured. So here we have to create some offset as well, because we have to hold the workpiece as well. So first we will create offset in diameter 2, and we have to create some offset in this direction for facing. So let's create 2 millimeters here. You can see 2 millimeters here, 2 millimeters in the diameter, and 40 millimeters in the chuck side. Okay, because we have to hold the workpiece as well. So let's write 40, or maybe we can add 30. Okay, so we have to hold this workpiece from here, and we have to start machining from here. Okay, when you are satisfied with the parameters, click here. Now we will set the coordinate system. So go to your coordinate system, and I will change it to stock vertex. It is currently part vertex. Here you can see the coordinate system. I will select here stock vertex, and here you can see this coordinate system, X in this direction and Z in this direction, which is correct for the lathe operations. Next is I will go to here setup, turn setup, and okay, it is correct. If you don't find this option extract machinable features, so go to here search bar and write extract machinable features, so you will find this option. Okay, in my SolidWorks 2020 it is here, so I will select this command, extract machinable features. So SolidWorks is smart enough, it automatically detects the machinable features. So it is saying that we have a facing operation, we have a turning operation, and we have a cut-off operation or a parting operation. Okay. Next we will create the operation plan for this job. So it is saying that first is the facing operation, face rough, then face finish, then turn rough, turn finish, and lastly the cut-off operation or the parting operation, where you have to remove this final workpiece from the chuck. Next operation is the generating toolpath. So I will click here, and now we can simulate the toolpath. So click here, simulate toolpath, and here it is showing the chuck and it is showing the workpiece, and here you can see the workpiece is holding by the chuck. So here we can see the simulation of the toolpath. We are given with different options as well. So I will click here run. So here you can see that we have made an error. We have to increase the offset distance to 40 millimeters, because it is currently interfering, or it is currently cutting the chuck. So I will click here OK, and then I will go to my stock manager, right click, edit definition, and I will change it to 40. Click OK, click yes. And now I will go to my simulate toolpath, and I will run this simulation. First of all, it would be the facing operation, second one would be the turning operation, and last one would be the cutting operation or the parting operation. So first one was the facing, then this is the turning operation, and last one would be the cutting operation. And here you can see that the tool is not interfering with the chuck. So when you are satisfied, click OK, and here you can see the difference as well. This is your workpiece which was held by the chuck, and this is the final output. Okay. So when you are satisfied, click OK. Here you can save the CL file or the cutter location file. I have created a dedicated video on this topic. What's the difference between CL file and G code? G codes are machine specific while CL files are not machine specific. Next is we will click here post process for creating G codes. And here I will change it to this one, tape file. Select save. I will check this box center line. I will check this box open G code file in SolidWorks. And I will play my G codes. So these G codes will be machine specific because I am using post processor. And I will click OK. Here you can see the toolpath. And now you can see the final G codes of your turning operation. So that's how you can create G codes of a turning operation in SolidWorks. Here is an important message as some students were approaching me. If you do like some personal guidance, I offer one-to-one session for engineers, students on AutoCAD, SolidWorks, ANSYS, different engineering topics, assignments, and even in final year project. You can reach me through my email and I will be providing my email in the description link. So that's it for today's tutorial. I hope you like this short tutorial. Still, if you have any question, any query regarding this tutorial or any other tutorial in my list, you can ask me in comment section. Thanks for watching and please subscribe to our channel for more informative and interesting projects. I will see you in the next tutorial. Thank you.